Hey, welcome to this talk. We're excited to be speaking here at FOSDEM 2022. I'm going to be talking about blurring your video backgrounds and virtual backgrounds. My name is Ravi. I'm an engineer at Daily. We are a WebRTC developer platform. Definitely feel free to reach out to us at any time. My email is ravi@daily.co. So today we're going to talk about video background effects. I think we're all familiar with background blurs and virtual backgrounds. So we're going to look at how these background effects work. We're going to build our own background effect, both blur and virtual background using Mediapipe. We're going to then take this background affected video stream and put it on a WebRTC call with Daily. And finally, we're going to touch a little bit on some implementation challenges in taking something like this from an MVP or a demo to finally putting it out in production. Most importantly, what I'm hoping to achieve from this talk is really talk about background effects as a template for building other machine learning video processes and applications, and how developers can use pretty much the same framework to build many other interesting use cases and applications. Before we really jump into the talk, let's talk a little bit about why now. Why should we talk about this specific problem at this point in time? Just to motivate this talk and lay the groundwork a little bit. Uh, I think we're sort of we're in an interesting time in this context. Somewhere in the middle of 2020, TensorFlow launched a WASM backend for writing machine learning inferences. WASM stands for WebAssembly. Why this is a big deal is that it enabled a way to run machine learning inferences on the CPU in a highly performant way. This was 10 to 20x faster than native JavaScript. And for small and medium-sized models, it's as performant as running something on WebGL. So this has been huge. Secondly, models are becoming smaller, and so they're becoming better at running in resource-constrained environments like your browser. Techniques like pruning and quantization mean that these models are becoming better at running inferences on edge devices. Thirdly, we're seeing a lot of pre-trained model repositories that are becoming available. TensorFlow Hub, AWS has a model marketplace. And so this means that these pre-trained models are really enabling developers to take advantage of all this and kind of build new applications. And you don't have to be a machine learning scientist or an AI scientist to build some of these applications. In a lot of cases, these models are working with really low latencies, 20, 30 millisecond latencies. And so they're already working in a really performant way. And lastly, in this context, just looking down the road, SIND support for WASM is being worked on. SIND stands for single instruction multiple data. Basically, it's a way to run parallel computation operations on the CPU. So in other words, what is already working decently well on the CPU is going to run potentially even faster very, very shortly. And all of this is just a long way of saying machine learning on the CPU is working well. Models are becoming smaller, models are becoming available to a lot of developers, and these models are going to get even faster without, any extra work. So, which really brings us to our talk here, which is the future is clear that we're going to see a lot more machine learning models and WebRTC applications. And which is why I think today we should talk about background effects and really focus on background effect as a template for building, other unique user experiences created by machine learning and AI models. So let's get started by trying to get a sense for how background effects work. This task in machine learning is called semantic segmentation. It is a task of assigning a category label to every pixel in an image. So, for example, in this particular image, every pixel could be classified as plain or potentially the sky, the background sky. This is, of course, a very simple example of a semantic segmentation problem. There are examples that are the more complex versions of this problem, typically like in self-driving vehicles, where the image or video frame, each pixel will be classified into 15, 20 different categories. Um, let's talk a little bit about how these models work, how they're built. Uh, One doesn't necessarily need to know specifically how all of these models are trained, but I think having an appreciation for what goes into this and what the outputs are like would it lends us really good intuition about how we could build applications with them. In machine learning, really, there are two parts to in machine learning. One is training a model or building a model from data. And then secondly, using a trained model and then running predictions or running inferences on this. Machine learning, is sort of the default approach that is working really well for some of these very complex problems is the approach of not writing out explicit rules in code, but instead sending a lot of labeled data and letting a densely connected network of nodes to figure out the right rules uh, to solve the problem. So in other words, you might send in an image such as the one on the left side to a neural network, and you would also provide it the desired image on the right side, and then you will, over multiple passes and different iterations, you will tune the weights in this neural network to kind of more closely give the desired output result. Um, the problem we're trying to solve in building background effects is essentially similar. We're building the task is similar in selfie segmentation is essentially semantic segmentation. We're trying to classify each pixel in a video stream or an image stream as whether it belongs to the foreground or on a person, or whether it belongs to the background. And if we can do that, then we can kind of build all these effects. Uh, Now that we've talked about how these models work, let's actually build our own blur and virtual background. We're going to use Mediapipe to do this. Mediapipe is an open source framework for building machine learning applications. They have some tons of great pre-trained models available for the use of the gate. Definitely check out their website and the demos and use cases there. Uh, let's take a look at what we're trying to build. We're trying to take an image or video stream, such as the one on the top, and then build these two video streams in the bottom. The video stream on the left side bottom has the background blurred out, while the person in the foreground is so sharp and crisp. And the video stream on the right hand side bottom has the background completely removed and it's been replaced by a background image. So let's take a look at some code snippets about how we can go about building this. First up, we need to get the raw camera feed. We'll use get user media to do that. Most developers are familiar with get user media. We then need to initialize our machine learning modeling library. We do that here. We're using the selfie segmentation model from Mediapipe. This works really, really well for users kind of within 2 meter distance from the camera. And we're using the landscape model here because in most cases our videos are segmenting users in a landscape aspect ratio. Once we've initialized the model, we now need to write a hook wherein we want to take every image frame from our video and send it to the segmentation model to run predictions or inferences on. We can use methods like request animation frames or put some timeouts on a web worker to do this. Daily, we use web workers to do this. We'll touch upon that very soon when we talk about the implementation hurdles in going to production and something like this. But essentially, this is a very simple step. We're going to take a single image frame from a video and send it to our segmentation model to run inferences on. So let's think back a little bit to that plane example. We've now sent it similar to the image on the left-hand side where we had the plane. We've now sent it this raw image, and we expect on the other side an image to be returned, a segmentation mask to be returned, where the pixel values will reflect a category label. And the categories in this case is going to be whether it represents a person or if it represents a background. So uh, being able to uh, render uh, a blurred video stream or background removed video stream on a canvas really this sort of brings us to the most exciting part of this project. We'll write our render on canvas method. So we start off by completely clearing the canvas. Next up, we take the segmentation mask that is returned by our selfie segmentation model, and using global composite operations, we're going to draw the segmentation mask on the screen here. The segmentation mask here is seen in red. On the top right-hand side, the raw image that we've sent to the segmentation model is shown there, so you can have a sense for how the segmentation mask relates to that image stream. Uh, the white in this image, technically, those pixels are transparent and not white. And what's in red is a category label. The value is 1 wherever the pixels are red, essentially. So once we've done this, we can then draw the raw unprocessed image stream on top of this with a global composite operation called source in. And what this does is it has the effect of deleting the background from the video stream. And you're left with this video stream where only the person in the foreground is in the video. So this is great. Moving right along, we can then take yet another raw unprocessed image frame and then apply a blur filter throughout. You can choose whatever blur filter radius that makes most sense for your application. You can take this blurred video frame that we just built and slide it behind the background removed video stream that we had built in the previous step. And if you slide it behind, it has this effect wherein you have the background completely blurred out, whereas the user on the protagonist in the front is in sharp, crisp clarity. And so this is fairly easy to do. And you've probably guessed already that this is essentially the same step even for background replacement. So for background replacement, instead of underlay the blurred image, you can underlay any sort of background image that you might be interested in, and essentially the same code and the same steps allow us to build a background replaced video stream. And so that was fairly easy. I hope you're looking at all of this and thinking that all of this is not too many lines of code. Once we've done this, so we've taken the raw video stream here, we've blurred it, and we've done background replacement. The last step is to take this background affected video stream and then put it on a WebRTC call. To do this, we use the capture stream method on the canvas element. It returns a media stream object. And essentially, in a normal WebRTC call, you have the camera stream and you send out that media stream on a WebRTC call. Instead, we'll just change that process a little bit, where we take that camera stream, we'll run this video process in that, we'll take that raw camera image, the image frame, we'll run segmentation on it. We'll have our render on canvas method that we just talked about. Then we'll capture a stream from that. And then instead of sending out the camera stream on our WebRTC call, we'll replace that with our processed media stream and send that out. And that's pretty much it. With this step, we have taken end to end, we've now placed a background replaced video stream or a background blur video stream on a WebRTC call. So all of this is great. Let's touch base very quickly on sort of what are some of the implementation hurdles, or what are some of the things that developers should think about going from an MVP or a demo of this product to kind of productionizing this. What are the challenges in that step? So the very first challenge to think about is really, CPU, right? CPU load and CPU related issues are one of the primary call quality issues we see at daily. And while building your own video process, it would it would make sense for the developer to continuously be thinking about how much it is increasing the CPU workload and how much of that CPU bump is justified in terms of the end user experience. At daily, we've been able to we found great benefit in kind of running dissimilar frame rates on our segmentation models on the raw video stream. And, I think from a developer point of view, it completely makes sense to think about how to squeeze out every ounce of CPU load that does not have a meaningful effect on the end user's experience. Secondly, background processes. Running these video processes on browsers has this unique challenge in that browser tabs can get backgrounded, and developers need to think about what the right behavior for the video process should be if the tab is backgrounded. Backgrounded tabs also go hand in hand with browsers throttling the performance, and so there are some roadblocks in this space. What we've found to work well at Daily is to take all of our video processors that are running and move it on webworkers in a background thread. And that has allowed us to keep these video processors running, even if a tab is essentially pushed to the background. But this is another very common roadblock that people run into. It's definitely something that you should think about. So coming back to sort of the talk, what have we seen so far? We've looked at background effects, how they work. We've built our own background blur and background replacement using Mediapipe. We've integrated this into a WebRTC call. And finally, we talked a little bit about some technical hurdles in taking something like this from demo to a production. At Daily, we want to enable developers to fully explore video processors and custom user experiences that they want to enable for their customers. And what we are enabling people to do is let the developers write their own, run their own machine learning models and write their own render on canvas method, and essentially have just these two methods that developers need to write, while Daily kind of does all the heavy lifting of, the camera stream, sending an image frame to the model to run inference on, capturing a media stream from that canvas, and then finally sending it out on a WebRTC call. All of this while, we want to hopefully abstract away all the technical challenges that we mentioned, which is backgrounding of tabs. Hopefully we can decouple developers from needing to worry about these nitty-gritty details And secondly, also the CPU load and optimizing frame rates. Developers can choose if they want to maximize CPU workload or to be conservative, and they can own all of that. And really, so what we're trying to do is uh, uh, let the developers kind of focus on their core customer experience or user experience, the product experience that they're trying to build, while abstracting away all the nitty-gritty details of enabling this on a WebRTC call and optimizing the CPU load and all of that. So that's what we're trying to do. Hopefully, we're going to see a lot more interesting applications very soon down the road. Uh, the last thing that I want to touch upon in this talk today is uh, background effects and virtual backgrounds are great, but what are some of the other applications and use cases that we can build on top of essentially a similar framework? So this is just to seed a few ideas. Maybe you have a fitness class use case. Mediapipe has a post detection model, and it will annotate someone's body pose in 3 dimensions and enable custom experiences like this. These models are running on the browser, with like 20, 30 millisecond latency. So you can easily enable a 30 frame per second uh, video with a video process running on this. Another interesting idea, you could enable live avatars on video. Mediapipe has a face mesh model. You could take these facial landmarks and overlay it on an animated video frame and enable avatars joining video calls. Among other ideas, you could track eyeballs. You can track attention. Um, you can also integrate gestures into your video call. We recently built this at Daily, wherein we let people control their video call, mute, unmute the camera with gestures. But gestures are a possibility, and you can enable various kinds of use cases, user experiences. Raising hands to ask questions in a larger call, high fives or other celebration hands or things like that. Various kinds of applications and gestures can be recognized in a video, and you can create unique experiences. And really, this really concludes my talk today. We talked about blurs, how they work, and all the implementation challenges. But I hope that the most important thing I leave you with today is that uh, background blurs and background replacement is merely one example. And the same framework could be used to build various other kinds of applications. And if anything, background effects are just the beginning, and the future holds way cooler applications. So with that, thank you so much for tuning in to my talk today. I hope you enjoy the rest of the conference, and thank you. You can reach me at ravi@daily.com. Thank you.